So today we're going to be talking about graphing parabolas in vertex form. That M got lost there. So it's assignment number 3. Vertex form looks like this. We have y equals a times x minus h squared plus k. And we're going to be talking about how this formula comes about later on. But for right now, let's just talk about how to graph it. Yesterday we did standard form, and so we're going to have two different forms when we start talking about parabolas: vertex form and standard form. And so let's go ahead and get started. Let's start with a problem from yesterday. This is a review problem from yesterday. Suppose a baseball is hit in the air with the height, and the height of the ball can be modeled by this equation. So the baseball is hit in the air like this. Hopefully it's one of our cubbies. How long will it take the ball to reach its highest point, which is this point right here? So what we're really looking for is the vertex. And so here we want to find the vertex, and we should recall that you can find the vertex by taking negative b over 2a. So in this particular case, we're going to have negative b, which is negative 96, divided by 2 times negative 16. And so that's negative 96 divided by negative 32, which is positive 3. So that means we would wait 1, 2, 3 seconds before the ball would actually get at its highest point. Then it asks, how high will the ball get? Well, we can find the highest point. That's the y value if we're graphing it here. The y value is at when x is 3. So we have the x value of 3. We're just going to plug 3 into the equation. And if I plug 3 in for this x, that's 3 squared. And so that's going to be 16 times 9, which is negative 144, plus 96 times 3 is 288, plus 3. Well, negative 144 plus 288 is 144, and 144 plus 3 is 147 feet high. And so we know that in 3 seconds the ball is going to be 147 feet high. And we just did that by finding the vertex. So let's move on and talk about today's topic. So we're talking about vertex form, which is y equals a times x minus h squared plus k. Just some things to note here. If we have y equals x squared, we know we're going to have a point at 0, 0. We're going to have a point at 0, 1. And if I plug 2 in, 2 squared is 4. If I plug negative 1 in, negative 1 squared is 1, negative 2 squared is 4, and I would get a parabola that looks like this. So how does the a value affect the graph? And so if we have an ax squared, what we would be doing is taking all of our values. If I had a table of values here, I would have the numbers I just plugged in, which were negative 2, negative 1, 0, 1, and 2, and I got 4, 1, 0, 1, and 4. If I have an a value, let's say for example that it is y equals 2x squared, then all of these values here would be doubled. I would take x and square it first and then double it, and I would get 8 and 2 and 0 and 2 and 8. And so instead of having a graph that looks like this, I'd still start at 0, 0, but I'd have a point at 1, 2, and at 2, 8. And negative 1, 2, and negative 2, 8. In other words, I'm going to have a skinnier looking parabola. Same thing, if a is negative, I would take all of these values and I'd multiply them by a negative number. So let's say it's negative 2. Then I would not have positive 8, but negative 8 and negative 2. And all of these numbers would be negative. And so that would mean that my parabola, I'd have 2 negative 8, 1 negative 2. My parabola is going to be opening down instead of opening up. So if a is positive, it opens up. If a is negative, it's going to open down. And the bigger that a is, the skinnier my graph is going to become. So let's see what happens when we add the k value. So the k value is over here. And so say we have y equals just 1x squared. That's our red parabola that's there. But if I add a value to it, so to get our red parabola, remember we had negative 2, negative 1, 0, 1, and 2, and we got 4, 1, 0, 1, and 4. Well, now what I'm going to be doing is taking all of those values, 4, 1, 0, 1, and 4, and adding a number to it. So let's say we add 3 to it. Let's say it's y equals x squared plus 3. Well, the 4 would become a 7, the 1 would become a 4, the 0 would become a 3, and then we'd have another 4, we'd have another 7. In other words, I'd have a point here at 0, 3, at 1, 4, at negative 1, 4, at 2, 7, and negative 2, 7, and my parabola, over here, my parabola would look like this. What happened is that my red parabola just slid up 3 units. So the k value just slides the parabola up 3 units. If it was negative 3, then it would slide the whole parabola down 3 units. If it was negative 5, it'd slide the whole parabola down 5 units. And so one of the things that you can see here is that the vertex would be slid down 3 units. So now let's take a look and see what happens to the parabola when we are subtracting an h value first. So we had our normal parabola, which was at negative 2, 4, and 1, and 1, and 1, and 2, 4. It looks something like this. But let's say now we want to subtract something before we square it. And so if I were to plug in my same values of negative 2, negative 1, 0, 1, and 2, it'd be hard to square. But let's say I wanted to make it 0 here. I wanted to square a 0. Well, let's say I started with an equation that looked like this. Y equals x minus 2 squared. If I wanted to plug in something that was a 0, the first thing that I'd have to do is plug in a positive 2. And so if I plug in a positive 2 here, then I'm going to have 2 minus 2, which is 0, and 0 squared is 0. And so that would give me a point right here at 2, 0. If I plug in a positive 1, then 1 minus 2 is negative 1, and negative 1 squared is 1. So that would give me a point at 1, 1. If I were to plug in a positive 3, well, 3 minus 2 is 1, and 1 squared is also 1, and that gives me this point. If I were to plug in a 0 or a 4, then I would get a 4 out. And so what I have is a parabola that was slid over 2 units to the right. Keep in mind, it's x minus 2. The reason it slid 2 units to the right is because I'd have to plug in a positive 2 to make that equal to 0. And so what we have here with this equation is we have an equation where the h and the k give us the vertex. So normally, if it's like just x squared, the vertex is at 0, 0. But if it's x minus a number, then I'm going to actually slide that far to the right. If it's x, if I add a number to it, I'm going to slide up that many units, and that would give me my vertex. The reason this is called vertex form is because the point hk is our vertex. And then we also know what the a value does to the graph, and so on. Let's take a look at some examples here. If I take a look at this first example, it is in vertex form. It would slide 1 unit to the left, and it would slide 3 units down. There's my starting point. There's my vertex. But then I also know that this parabola is going to open up, and it's going to be kind of skinny. So when I plug in my different values for my x, I can plug in now a negative 1 gives me a negative 3, but then I can plug in a 0, a positive 1, a negative 2, and a negative 3. And if I do that, I'm going to have negative 1 here and here, so that's going to give me this point here and this point here. And I'm going to get a positive 5 when I plug in a 5 or a negative 3, which 1, 5 is here, and negative 3, 5 is here, and my parabola is going to look something like this. Do the same thing with the next equation. I know this one's going to open down because the a value is negative. My vertex is going to be at 2, 4. So it's positive 2 because it's kind of the opposite of what you would think. I have to plug in a positive 2 to make that equal to 0. And I'm going to slide up 4 units. And so I know it's going to open down. So then I could make my x and y table. It's going to open down, and I would plug in like 1 and 3, and I would get 3's for both of those. I can plug in a 0 or a 4, and I would get 0's for both of those, and my parabola is going to open down and look something like that. The key here is that the h and the k give you your vertex. So let's move on and take a look at this situation. We want to write an equation in vertex form of a parabola with vertex at 2, 3 that goes through this point. Well, we're going to use vertex form to do this. Vertex form, remember, is y equals a times x minus h squared plus k. And we know that the vertex is 2, 3, And so we can go y equals a times x minus the h value. Well, that's the x value, which is x minus 2 squared plus k, which in this case is 3. So I would be done if I knew the a value, but I don't know the a value. So now what I'm going to have to do is plug in this point to figure out what my a value is. This is just a normal x and just a normal y. In other words, when y is negative 5, I'm going to plug negative 5 in for y. I have my a value. X is 4 squared plus 3. So now I can use this equation because I only have one variable, and that's a. I can figure out what a is. So I'm going to have negative 5 equals a, but then I know that 4 minus 2 is 2, and 2 squared is 4. So a times 4 plus 3. If I subtract 3 from both sides, I'll have negative 8 equals 4 times a, and if I divide by 4, a is negative 2. So that means my equation is going to look like this. It's going to be y equals, my a value is negative 2, then it's going to be x minus my h value. Well, that's my k value, that's in my vertex, that's minus 2, squared plus 3. And this is an equation in vertex form of a line that has this vertex that goes through this point. Let's say we have something like this. It says rewrite this equation in vertex form. So one of the things that we will learn eventually is how to complete the square. That'll make this process maybe a little bit easier. But we can find the vertex here. We know that the vertex is negative b over 2a. So that's 2a. So it's going to be positive 4 over 2 times 1, which is positive 4 over 2, which is 2. So I know the x-coordinate for the vertex is at 2. And if I plug that in to figure out what my y value is, 2 squared is going to be 4. Minus 4 times 2 is minus 8 plus 6. Well, 4 minus 8 is negative 4. Negative 4 plus 2 is 2. So that means my vertex is at the point 2, 2. So, and my a value here in standard form matches my a value in vertex form. So that means my equation is going to look like this. Y equals 1. Here the a value is 1, so my a value here is going to be 1. And then it's going to be x minus 2 squared plus 2. So there's our equation in vertex form. One of the things that you're going to be able to want to do is to go from vertex form to standard form. So can we take this equation and put it back in vertex form? Well, in standard form, I mean. So what we would do is we would square the x minus 2. That means we'd have to FOIL it. We would take x minus 2 times x minus 2. So that's going to give us x squared minus 2x minus another 2x and then plus 4. Well, that's x squared minus 4x plus 4. That's what this is squared. I can multiply it all times 1, which is going to give me the same thing, and then I have to add 2 at the end. Well, if I simplify all of that, I'm going to have x squared minus 4x plus 6. And you can see now I'm back in standard form. So you should be able to convert from standard form to vertex form and from vertex form back to standard form. Let's try it with a new problem. We're going to rewrite this equation in standard form. So this is a little bit different. And actually I'm going to change this so it's not negative x. Let's say it's negative 3. So if I'm going to rewrite this in standard form, I'm going to start by taking the x plus 2 and squaring it, which means I'm going to FOIL it. X plus 2 times x plus 2. Well, that's x squared plus 2x plus another 2x is going to be plus 4x plus 4. I'm going to multiply all that times negative 3 and then add 4. So then I'm going to, if I distribute my negative 3, it's going to be negative 3x squared minus 12x minus 12 plus 4. And my final answer is going to be y equals negative 3x squared minus 12x, and then negative 12 plus 8, or plus 4 is negative 8. And so in standard form, I would have y equals negative 3x squared, that's squared right there, minus 12x minus 8. So this is what we're going to be doing on our homework assignment for tonight. Good luck with that, and we will see you tomorrow in class.